For decades, the Cold War wasn't a war of bombs and bullets. It was a war of silence, secrecy, and fear. Two global superpowers watched each other from across oceans and borders, both knowing that if a real war ever started, it would end the world in minutes. In that fragile peace, one idea dominated military thinking on both sides. If you can see the enemy coming, you have a chance. Radar was the shield. Radar was the warning. Radar was the last line between survival and total annihilation. And for years, the Soviet Union believed its shield was unbreakable. What they didn't know was that deep inside classified facilities in the United States, engineers were quietly building something that would make that shield almost meaningless, long before stealth aircraft became public knowledge. American engineers were obsessed with a single question: how do you strike an enemy who believes they can see everything? In the early days of flight, the problem was simple. If a soldier on the ground could hear or see an aircraft, defenses could be ready. The first attempts at making planes invisible were almost childishly simple, like using transparent materials to try and blend the aircraft into the sky. But war, as it always does, evolved. And by the time radar became the king of the battlefield, invisibility was no longer about fooling the human eye. It was about defeating physics itself. Radar works on a basic principle: send energy out, let it hit something, and wait for it to come back. If it comes back, you've been spotted. So the real challenge wasn't to hide an airplane, but to control how radar energy behaved when it struck one. During World War II and the years that followed, engineers on both sides started noticing strange things. Certain shapes reflected radar signals poorly. Aircraft with fewer vertical surfaces, smoother lines, and unconventional designs sometimes appeared as weaker, fuzzier blips on radar screens. These were just small clues, but they hinted at something revolutionary. Shape mattered. The United States tested all sorts of ideas. One of them was altitude. The thinking was, if an aircraft flew high enough, maybe radar just couldn't reach it. This idea gave birth to incredible machines like the U-2 spy plane, which soared far above conventional air defenses. But the Soviets shattered that illusion. Their advanced radar systems proved that height alone was not invisibility. The U-2 could be tracked, and once it was tracked, it could be targeted. That moment was a critical turning point. It forced American planners to accept a hard truth. Speed, altitude, and distance were no longer enough. A completely new approach was needed. In the 1970s, that new approach finally became possible. Stealth technology stopped being a game of guesswork and became a game of mathematics. American engineers began using advanced computer models to predict exactly how electromagnetic waves would bounce off complex surfaces. Ironically, some of the core scientific theories they used were actually based on earlier work by Soviet scientists on wave behavior. But the United States had a critical advantage that changed everything: massive computing power, precision manufacturing, and the industrial might to turn theory into hardware at an unprecedented speed. What emerged from those calculations looked absurd. It had flat panels and sharp, jagged edges. There were no graceful curves, no sleek, aerodynamic lines. The shape resembled a faceted gemstone more than an airplane. Engineers joked about it. Critics dismissed it out of hand. Some even believed it would never be able to fly at all. When radar waves hit those carefully angled surfaces, they didn't bounce back to the radar dish. Instead, they were scattered away, harmlessly, into empty space. With the backing of DARPA and Lockheed's legendary Skunk Works division, the United States turned this wild theory into reality. The secret prototype, known as Have Blue, proved that stealth was not a fantasy. It was a real, tangible technology. Now, the aircraft itself was dangerous, unstable, and almost impossible for a human to fly without assistance. But by then, fly-by-wire computer systems had matured. Computers could make thousands of micro-corrections every single second. Keeping an aircraft stable, even when its physical design defied all the traditional rules of aerodynamics. For the very first time in history, invisibility was no longer just an idea. It was a measurable, probable fact. And from that incredible breakthrough came the aircraft that would redefine modern warfare, the F-117 Nighthawk. The F-117 wasn't designed to win dogfights. It wasn't built to set speed records. It had one single, terrifying purpose: to go where no other aircraft had ever been able to go, strike a target with pinpoint precision, and leave without anyone even knowing it was there. Every single element of the F-117 was dedicated to that mission. Weapons were hidden inside the fuselage to maintain its clean, radar-defeating shape. The engine inlets were covered with special grills to block radar reflections from the spinning turbine blades. The entire aircraft was coated in special radar-absorbent materials that soaked up energy instead of reflecting it. Even its heat signature was carefully managed to make it harder for infrared sensors to track. Nothing was accidental. Every surface, every angle, every panel was the result of intense calculation. To a Soviet radar operator staring at their screen, the F-117 wasn't an aircraft in the traditional sense. It didn't appear as a clear, solid target. Most of the time, it barely appeared at all. Just a weak, confusing signal that flickered on the screen for a moment before disappearing. It was something that could easily be dismissed as atmospheric interference, a flock of birds, or just a glitch in the equipment. And that uncertainty was the real weapon, because a defense system that cannot trust its own sensors is a defense system that is already defeated. From the Soviet perspective, the implications were bone-chilling. Decades of investment and billions of rubles spent on vast networks of radar stations, missile batteries, and early warning systems were suddenly in question. If one aircraft could slip through their defenses completely undetected, how many others might exist? What else was flying out there in the dark that they couldn't see? In the high-stakes game of the Cold War, fear was just as powerful as firepower. And the existence of stealth technology injected a massive dose of doubt right into the heart of Soviet defense strategy. The F-117 remained hidden from the public for years, a quiet, decisive advantage held in reserve. When it was finally revealed to the world, it marked the beginning of a new era of warfare, an era where conflicts would be shaped not just by the number of tanks and planes, but by engineering materials, science, and information. It was definitive proof of what American innovation could achieve when science, industry, and strategic vision all came together. Yet, even this incredible achievement had its limits. Stealth was never absolute invisibility. It was a careful balance of technology and tactics, not magic. And one night, years later, over the skies of Serbia, an F-117 would be shot down, reminding the entire world that no technology, no matter how advanced, is ever truly invincible. That story and what it revealed about the true limits of stealthies coming up next. Thanks for watching, and be sure to subscribe so you don't miss it.